chapter 7 today, huh?
We're on 7.4.
Are we? Yes. Okay, so there were two last questions. So last time at the end we were talking about rationalizing the denominator, and we solved these questions and this one now. Okay, so when we want to rationalize a denominator, we multiply the fraction to the same thing as denominator, divide by denominator, because this one is 1. We are just going to get rid of this radical in denominator. So now the denominator we have is slightly different from what we saw before. It's a kind of combination of number and radical. So we are going to use the formula we had in previous chapters. So when we had a minus b multiplies to a plus b was equal to a squared plus b squared. We use this to get rid of that denominator. So this says if we have the same thing in this parenthesis, just with a different or opposite sign, we can square the first number. Actually, this one is minus 2 squared. Minus the square of this radical. So we can get rid of radical in this way. Because you know, square of a radical with index 2 is the number inside the radical. So this second part you see in other parentheses is conjugate of 3 plus radical 2. So this one is conjugate of this one, and this one is conjugate of this one. So whenever we have something in this form, we find a conjugate of this and multiply this whole fraction by the conjugate of this denominator divided by the conjugate of the denominator. So now the denominator are going to multiply together, and the numerator also will multiply to the thing we have in top. So look at this, we already solved this part, right? It will be a squared minus b squared, okay? So we just replace this result in denominator. So what we will have, 5 multiplied 3 minus radical 2 divided by 9 minus 2, which is just an integer 7, right? Correct? So 9 minus 2 is 7, and then let's multiply this 5 by all the terms inside the parenthesis. So we will have 15 minus 5 radical 2. At some point we can simplify the numerator and denominator, but now here we cannot. Okay, so the next example says we have 7 plus radical 3 divided by radical 7 minus radical 3. So what is the conjugate of this denominator?
1.
Conjugate of this will be radical 7 plus radical 3. Correct? So now you know conjugate of, for example, a minus b is a plus b. Okay? Conjugate of a plus b is a minus b. So the sign is different. So what we should do, we should multiply this whole fraction by the conjugate of this denominator, divide by the conjugate of denominator, correct? So which is radical 7 plus radical 3. Radical 7 plus radical 3. Right? So let's write them down. Be careful, don't have a be careful about this sign. Okay, so a minus b multiplies to a plus b, correct? Like here, a minus b multiplies to a plus b. So the result is a squared minus b squared, correct? So we'll have radical 7 squared minus radical 3 squared, correct? Radical 7 squared minus radical 3 squared. To solve this one, you can use FOIL, correct? Or you can use this one, radical 7 plus radical 3 whole thing power 2, because you are multiplying this to itself, right? So if we have a plus b power 2, this one is a squared plus 2 times ab plus b squared. Do you remember this? This one? So I can use the same thing here. A plus b squared. So the result is a squared plus 2 times this one multiplied to this one plus b squared. Correct? So a squared plus 2 times a b plus radical 3 squared. In denominator now, because radical 7 is power 2, will be 7 minus 3. Is this correct? Do you have any question here? I'm just using formula from past and some of kind of radical rules we saw last lecture. For example, radical a power 2, because the index is 2, this index will cancel with the power and then 7 comes out, right? Same thing to this one. So 7 minus 3 is 4. Radical 7 squared, 7 comes out. 2 times. Let's write this down and then we will talk about the mid part. So radical 7 multiplies to radical 3. Both of them have the same radical with the same index, correct? So we multiply them both together under one radical. So we will have radical within x2. 7 multiplied 3 is okay, so in top of this fraction, there are 2 like terms. We can add them, right? 7 and 3 is 10 plus 2 radical 21 divided by 4. Okay, still I'm not done. Why? Because I see that 10 plus 2 radical, what was radical, what? 21 has something in common with this denominator 4. What is common between all of them? What is the greatest common factor? 2, right? So let's factor out 2 here. So we will have 5, am I right? Plus radical 21 divided by 4. Two and 4 will cancel, okay? So 5 plus radical 21 divided by 2. Do you have any questions? So rational equation, check in section 5. So here, same as always, whenever we learn something like, rational expression, quadratic function, anything, at the end we are solving that function for x or y, a variable, right? So now here we want to see how we can use all these properties we learned to solve a rational equation. If we have an equation involving with a radical. So as you see, this is an equality. Radical 2x plus 9 is equal to x plus 3. So the aim is to solve this equality for what? X, exactly. Whenever you have radical equality like that, you will keep radical on one side and you will move everything else to the other side. So here in this case, radical is on one side itself, right? So what I mean by moving everything to the other side, For example, if you had this, what you would do? Bring this to the other side. Correct? Or if you had negative x on this side and 3, the first step is to put that x on the other side. You're isolating radical. Correct? So now, to solve this, when everything is okay like that, you are going to square the both sides, because you know radical a with index 2, if we square it, a comes out, right? So with doing this, whatever we have on the radical comes out. So what comes out? 2x plus 9. But you have to calculate this one, right? So this one is a plus b power 2. A squared plus 2 times ab plus b squared. Do you remember this? We just solved. We just used this. So it will be x squared plus 6x 2 times 3 multiplied x, right? 2 times x multiplied 3 is 6x plus 3 power 2 is 9. Did we talk about quadratic equation? Minus b plus minus radical. Next chapter. So, we want to solve for x, right? Let's organize this. Bring everything to the other side, or this side. Actually, let's keep it this side. Why? Because if I bring everything to the other side, x squared will have a negative sign, right? So let's keep it this side. So x squared plus 6x plus 9. 9 goes to the other side, becomes negative 9, right? 2x goes to the other side, becomes negative 2x. So we have 0 here. Correct? So combine the like term. So obviously this one cancels with another 9. Then 0 is equal to x squared, 6x. Negative 2x is plus 4x. How to solve this for x? So we learned factoring in previous chapters, right? To solve this kind of question, this kind of equation. So now what is the common factor between these two? X, correct? So let's bring out x. If we bring out x from the first term, just one x remains, right? If we bring out x from the second term, what remains? 4 remains. Correct? So can I write this down in this form? X multiply x plus 4 equals 0. Yes, huh? I can do this. So now you will see easier. A multiplies to B is equal 0, zero product, right? So what this means either A is equal 0 or B is equal 0. Either X is equal 0 or this parenthesis is equal 0. So X equal 0 or X equal negative 4. Do you understand this? Do you have any question? No. Okay, so let's solve one more question. Not one more, more and more. Okay. We have radical 10x plus 5 minus 1 equal 2x. So the first step is to exactly isolate this radical and move everything to the other side. So we will have radical 10x plus 5 equal to 2x plus 1. So what should I do now? Square both sides. Correct? So if we square both sides, 10x plus 5 comes out, right? So now we have 10x plus 5 is equal to 2x plus 1 power 2. We should solve this. Correct? So I see something I really like to solve in this way. Just now I saw it. Let me solve the way I see right now, and then I will continue solving another way, the way we did previously. So look at this. What is common between these two? 2 is common, right? What remains from 10x?
5x.
Oh, sorry. What is common between these two? 5. What you said 2? 5, right? So what remains? 2x plus 1. Do you see that? You have 2x plus 1 on both sides. So let's divide both sides by 2x plus 1. Can I do that? Yes, because it's common on both sides, right? Let's divide both sides by 2x plus 1. What remains on this side? 5. What remains on this side? So if you cancel one of these with one of these, just one remains, right? Just one of them remains. Am I right? So now how easy is that to solve 2x plus 1 equals 5 for x? It's so easy, huh? So we will solve 2x plus 1 equals 5. So 2x is equal to 1 goes to the other side, negative 1, 5 minus 1. Correct? 5 minus 1 is equal to 2x. So 2x is equal to 4. So x is equal to 2. So this just came to my mind because I thought, okay, if I bring out 5, I will have the same thing on both sides and I can cancel out. But if we didn't see that, if I didn't see that, how we should solve this? Exactly, we should say 2x squared plus 2 times 2x multiplies to 1 plus 1 squared, right? So it will be 10x plus 5 equals 4x squared, right? Plus 4x plus 1. And then 4x squared plus 4x minus 10x. I'm bringing this to the other side. I'm bringing this 5 also to the other side. Plus 1. Combine the like terms. You will have 4x squared minus 6x minus 4. So to solve this kind of quadratic equation, what we do at first, we bring out all the common factor, right? So what is common between all of them? 2. So we have 2 multiplies to 2x squared minus 3x minus 2 equals 0, and then we give up. It's difficult, huh? But see how easy it was? When I saw I can bring out 5. Do you see that? So now we have to solve this. Okay? We should solve this. Do you remember a x squared plus b x plus c? So we multiply a and c to find ac, right? Which is 2 multiplies to 2, negative 4.
And then we break up b into 4, equal to 4.
So what about this one? We say negative 4 is negative 1 multiplies to 4, for example, because we are going to reach this one, right? If we add this 2. Am I right? Or we can say negative 4 multiplies to 1.
Then 2 times 2.
2 times 2, if you add them or subtract them, you don't get 3x.
Oh,
That's why. Alright? So I think this one is the best one. Correct? And then we should break down the bx to negative 4x plus 1x, right? So let's do it.
and then we group after.
Exactly. fraction. I hope we did everything correct. Did we? So we have 10x plus 5 here, 2x power 2, 2 times 2x multiply 1. You try to group this. You try to find the answer using grouping. Do you remember grouping? You match two of them, factor out the common thing from the first group, factor out the common thing from the second group. Do you remember? Do that, please. I just want to check to see everything is correct. So 1 squared. Okay, so did you see one thing here? So 4 is equal to 2x. X is equal to, no, what is that? I don't know, I did something wrong. But let's do this. Okay. This group, this is a group, right? What is common between these two?
2x.
2x multiplies to x minus 2 plus, and then here we don't have anything common. 1 is coming out.
I got a question. When do we factor completely? When do we have to factor completely?
Factor completely.
No, when?
When factor completely. What do you mean exactly?
Like to, like when the one we factor without, the one we didn't factor completely. How do we know when to factor it completely? Can we just leave 2x squared minus 3x minus 2 like that? Or do we have to?
Oh, okay. At this point?
Yeah, like how do
At
we
this
know?
point.
Yeah, how do we know to factor completely?
We should try different methods. You know, this one, for example, the closest method is this one. If it works, we have to factor it. We have to continue.
Oh, so if it works, then we have to do that?
Otherwise, we will have a prime quadratic function and we cannot continue. Correct? So, yeah, as soon as we see a quadratic trinomial, we have to try different methods to see if they work, and we have to complete all the steps. Otherwise, we stop here. Okay? Okay, so what is common between these two?
X minus 2.
X minus 2. So keep this 2 outside. X minus 2 multiplies to 2x plus 1. Okay. So what is the answer? Let me continue somewhere else. So we should use zero product, right? What we have 2 multiplies, 2x minus 2 multiplies, so 2x plus 1 equal to 0, right? Zero product. A, B, C. Definitely this one is not 0, but either this one or this one should be 0, right? Okay, x minus 2, 0, 2x plus 1, 0. X is equal to 2, 2x is equal to -1, x is equal to -1/2. So now we understand. At some point when we don't use factoring, we are going to miss one of the factors. Look, I solved it here and we reached just x equal 2 by canceling. But here, when we factored out everything completely and we solve using factoring method, we have 2 values for x. So not always canceling a binomial is a good thing, because we are losing something. So I factor out a binomial, 2x plus 1. That's why I'm losing one of the factors of x by dividing everything by 2x plus 1. That was a good experience. So now you understand what happened? So when we completely went through everything and solved factoring, we have 2 answers for x. But when that side I canceled a binomial, here I'm canceling 2x plus 1. So there was a value for x here that I am canceling. So that is not always a good thing. And also, I know for sure most of the time you are going to lose some imaginary answer for x if you do that kind of things. Okay, so we said imaginary number. Actually, in this chapter we have imaginary number. We have to talk about imaginary number too. Let's see, where is that? Yes, next section we are going to talk about imaginary numbers. Okay, so next example. Now we have 2 radicals. So for sure you should go back and review all the formulas we had in factoring chapter. All those formulas we used, have to remember them again. Okay, so we have 5x plus 1 negative 3x on the radical equal to 1. Okay, so now we have 2 radicals. So what you would do, isolate all the radicals one side. Or bring one of the radical to the other side. You can do both ways. Either keep both radical on one side or bring one of them to this side. But let's start with this one. We have both of radicals on one side. So what we are going to do, you should square the both sides, right? So we are going to square both sides. So it means we have a minus b power 2. We should write down a squared minus 2 times ab plus b squared. Right? One radical is a, another radical is b. Radical 5x plus 1 power 2 minus 2 times radical 5x plus 1 multiplies to radical 3x. Right? AB. 2 times AB. Correct? A squared minus 2 times AB plus B squared equal to 1 squared is 1. So radical 5x minus plus 1 comes out. I mean, whatever we have on the radical 5x plus 1 comes out. Minus 2 times, we have 5x plus 1, radical 3x. We can combine them, right? Because we know that both of them have the same index. Then plus 3x comes out. So still we didn't get rid of all the radical. Still we have radical. So what to do next? Can you guess? Oh, actually simplify, yes. She's right. We can simplify this one and this one. Correct? So if we do that, what we will do after that? After simplifying, let's say I have 8x plus 1 minus 2 times radical 5x plus 1 multiplies to 3x equal 1. So what to do here? We are going to move everything to the other side, keep the radical one side. Let's start over. So we keep this one. Oops. 5x plus 1 multiplies to 3x equal to 1. We have negative 2x. 8x goes to the other side. Negative, this 1 also goes to the other side too. Correct? So cancel these. What else? Actually, we can continue to isolate radical. Means get rid of that negative 2. Means divide both sides by negative 2. So we have radical 5x plus 1 multiply 3x equal to negative 8x divided by negative 2. Right? Okay, radical 5x plus 1 multiplies to 3x equal to 4x. What to do next? We are going to square both sides to get rid of radical, right?
Yes.
So we follow the same pattern 2 times. So this one is much easier. We have 5x plus 1 multiplies to 3x. Everything comes out, right? And then 4x power 2 is 16, x squared. Correct? So now multiply these two. So 3x multiplied to 5x is
15x squared.
x squared plus 3x multiplies to 1 is 3x. So what? Do we have like terms? We have like terms, huh? So we should bring everything to the one side or other side, okay? So let's bring this to the other side. We have 15x squared minus 16x squared plus 3x equals 0. So what next? So what remains? Negative x squared plus 3x equals 0. Subtract 3x. What else? What we do? Here is easy, please. Huh? What? X, right? Factor out x, okay? So x comes out. We have negative x plus 3 equals 0. What else? What is the answer? Right? So x is equal 0 or x equal 3, right?
Yes.
So here x equals 0 or x equal 3, because negative x plus 3 equals 0 is 3. X is equal to 3. Okay? Okay, so this one, same thing. You square both sides to get rid of radical ones, and then again, if any radical remains, you have to again square both sides to get the radical, to cancel the radical, okay? So now imaginary numbers, complex numbers. Section 6, simplifying expressions involving complex numbers. Oh, So if you remember, if our radical has a index like 2, 4 even numbers, we couldn't have any actually negative number on the radical. So for example, if we had negative 4, because the index is 2 here, we couldn't answer this. We said the answer is not a real number. But if it was 4, what is the answer? 2, correct? So in that case, what we do? We separate this to 2 parts. -1 multiplies to 4. Then with radicals rule or properties, you can separate them to 2 radicals multiplied together because the index is the same. So now you have -1 multiplies to what? Radical 4 is 2. This -1 on the radical you see here, we call this imaginary number. So we define it like this. Radical -1 is equal to I and whenever you reach this point, you can easily say, okay, we know radical -1 is I, and we have 2 multiplies to I. If you want to arrange this, we can rearrange it in this form. So the answer will be 2I. And I is an imaginary number. So what is I power 2? Huh? What is that? I power 2 means I squared both sides, right? So what comes out from here? -1. -1 comes out if you say this one power 2, this one power 2. Whatever you have on the radical comes out, correct? So now you know I is radical -1, but I square is -1. And then we will continue, we will have the rest of like I power 3, I power 4, all. Okay, so now, when you have a kind of combination of, oh, look at this. It says the imaginary number is defined, I is defined as follows. The set of imaginary numbers consists of numbers of the form bi, where b is a real number and b is not equal 0. So this one is like the way we wrote down 2i. 2 is a real number, I is an imaginary number. Now if we have combination of imaginary number and kind of integer, like this form, a plus bi, when a is a real number and b is a real number, and as you know I is imaginary, we call this a complex number. So complex number is a combination of real numbers plus or minus a real number multiplied to the imaginary number. This part is the real part, and this part is the imaginary part. Name is imaginary part. We already talked about conjugate. Conjugate of A minus B is A plus B. Conjugate of A plus B is A minus B. So now imagine you have a complex number. Conjugate of A minus BI is A plus BI. Conjugate of A plus BI is A minus BI. If you want to combine some imaginary number, let's say we have 3 plus 2i minus 5 minus 8i. So this is the real part, this is the imaginary part, real part, imaginary part. Correct? So first of all, you will apply this sign to each of these terms. So you will have 3 plus 2i minus 5 plus 8i. Then these two are the like terms, these two are the like terms. So you will add these two, and then you will combine these two, you will combine these two, and now you have another imaginary number. So this is the way we add or subtract them. So imaginary terms are the like terms, and real terms are the like terms. Okay, so now let's solve more imaginary number, more radical using imaginary number. So let's say we have radical 45. So what I said, instead of negative 45 here, you will write down negative 1 multiplies to 45, correct? Negative 1 multiplies to 45. Then you can separate them. Instead of negative 1 on the radical, you can write down I. Now we should solve radical 45. So radical 45 is, so 45 is two numbers multiplied.
9 times 5.
9 multiplied 5, right? So I multiplies to 9 multiplies to 5. What is radical 9?
3.
3. So far 3 comes out, 5 stays inside the radical. Okay? Do you have any question? So now another question. We have radical -16 multiplying -25. Okay, so what is -16 on the radical?
4,
-4. What about imaginary number? Let's go slowly. So we have -1 multiplied 25, right? Then we have -1 multiplied radical 16. -1 multiplies to radical 25. Okay? So instead of each of these -1 on the radical, I should write down I. Okay? So we have I. Radical 16 is 4. Radical 25 is 5. So we have 4 multiply 5 multiply I multiply I. Correct? Do I have I square? Yes. Because x multiplies x is x square. I multiply I is I square. Right? And then 4 multiply 5 is 20. So I will have 20 I square. I square. I square is -1. 20 multiplies to -1. We have one complex number multiplies to the other one. We use FOIL, huh? We use FOIL. Seven multiplied 2 is 14. 7 multiplied 3 is, and then 6 I multiplied 2 is, exactly. And then 6 I multiplied 3 I is negative 18 I squared. Combine the like terms. Negative 12 I plus 21 I is three. Positive, negative. So we have 8, 1, 9. Am I right?
Yeah, 9.
Minus 18 I squared. What should I write down in for I squared? Negative 1. Correct? So we have 14 plus 9i plus 18 have like terms again. Okay, so do you have any questions so far? These are the list of I square, I power 3. So let's see what happens. So I power 3 is equal to I power 2 multiplies to I. Am I right? Correct, huh? So I power 2 is negative 1 multiplies to I. So we have negative I equal to I power 3. I power 3 is negative I. Correct? Then I power 4 is I power 2 power 2. Correct? Right? Then I power 2 is negative 1. Power 2 is 1. So I power 4 is positive 1. And then the rest is exact same. You just put the previous number and you will, for example, I power 5 is I power 4 multiplies to I, right? And I power 4 is 1. 1 multiplied I is I. Correct? Then it says, so what about I power 36, for example? We can use all the properties of power. So I power 4 power 9 is I power 36, right? 9 multiplied 4 is 36. So instead of I power 4, we have positive 1, and the result is 1. Correct? Then I power 27, it says, we can write it down in this way. I power 24 plus 3. Right? And then we can have I power 24 multiplies to I power 3. Then for I power 4 we can write down, I power 24 we can write down I power 4 power 6, because 4 multiplied 6 is 24, right? Multiplies to I power 3. For I power 4 we have 1. For I power 3 we found negative I. So it will be 1 multiplies to negative I, which is negative I. So we'll simplify that to either 1 or negative 1 or some positive negative I, actually. Do you have any questions? So the rest is the way we solve the conjugate, we solve the radical using conjugate question. So you should already know how to do this. Do you have any other questions? So we are done with chapter 7. If you have any question, ask me. Otherwise, we'll see you on Monday.